Now, in this lecture, we will find the area of the green shape. In the drawing, we have triangle ABC. We know that angle BAC equals to 60 degrees, and also we know that BF equals to CF equals to DF, and that equals to EF. And we also know that the area of triangle DBF equals to 8 square units, and the area of triangle EFC equals to 15 square units. And we want to find out the area of the green shape, or the area of quadrilateral ADFE in the green color. First of all, we will define angle ABC of triangle ABC as B, and we will define angle ACB of triangle ABC as C, and we know that the sum of the angles in any triangle is equal to 180 degrees. Therefore, in triangle ABC, 60 degrees plus B plus C must be equal to 180 degrees. So 60 degrees plus angle B plus angle C must be equal to 180 degrees, according to the rule that I mentioned, that the sum of the angles in any triangle is equal to 180 degrees. Here we will subtract 60 degrees from this equality, and we will get that B plus C equals to 120 degrees. Actually, we have a new rule number 1, that states that in front of equal sides in the triangle, there are equal angles. So actually, if we have triangle ABC, and we know that side AB equals to side AC, those two sides are equal to each other, then the angles that are in front of those sides, that is to say angle ABC and angle ACB, are equal to each other. So angle ABC equals to angle ACB according to rule number 1. So actually, in our drawing, we have triangle DBF. We know that in triangle DBF, this small triangle, we know that BF equals to DF, BF equals to DF. Therefore, according to rule number 1, those two angles that are located in front of equal sides also must be equal to each other. So if this angle is better, then angle DBF must be equal also to B. If this angle equals to B, then this angle must be also equal to B, because those two angles are located in front of equal sides, therefore they are equal to each other. That is to say, those two angles both are equal to B. And also in triangle FEC, we know that FC equals to EF, and in front of EF we have angle C. So in front of FC we have angle FEC. So those two angles are located in front of equal sides. Those two angles are located in front of equal sides. Therefore, they are equal to each other. So if this angle equals to C, then this angle must be also equal to C. Okay. In the next step, we will define angle DFB as P, and we will define angle CFE as Q. And we know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle DBF, the sum of the angles is equal to 180 degrees. That is to say, B plus B, that is 2B plus P, must be equal to 180 degrees. Okay. Two B plus P equals to 180 degrees. We will subtract 2B from this equality, and we will get that angle P equals to 180 degrees minus 2B and the same thing is true in triangle FEC. We know that in triangle FEC, the sum of the angles are equal to 180 degrees. That is to say, C plus C, that is 2C plus Q. 2C plus Q must be equal to 180 degrees. Okay. 2C plus P equals to 180 degrees. We will subtract 2C from this equality, and we will get that here the sum of the angles is equal to 180 degrees. That is to say, 2C plus Q equals to 180 degrees, and we will subtract 2C from this equality, and we will get that Q equals to 180 degrees minus 2C, and we have already found out that P equals to 180 degrees minus 2B. So we actually found out that angle Q equals to 180 degrees minus 2C, and angle P equals to 180 degrees minus 2B. In the next step, we will add Q and P together. We will add Q to P, and we will get that Q plus P equals to 180 degrees plus 180 degrees equals to 360 degrees. Minus 2C plus minus 2B is minus 2C minus 2B. Here we'll take minus 2 as a common factor of this expression, and we will get that Q plus P equals to 360 degrees minus 2 times, in the brackets we will have B plus C. Okay, but we have already found out equation number 1 that B plus C equals to 120 degrees. Therefore, we will substitute B plus C in equation number 2. We'll substitute B plus C in equation number 2 by 120 degrees. We will get that Q plus P equals to 360 degrees minus 2 times, and instead of B plus C we will write down to 120 degrees. So we will get that Q plus P equals to 360 degrees minus 2 times 120 degrees is 240 degrees. So Q plus P equals to 360 degrees minus 240 degrees is 120 degrees. So we got that Q plus P equals to 120 degrees, and we have already found out that B plus C also equals to 120 degrees. Okay. In the next step, we will connect together points D and E by a straight line. And then we will calculate the size of angle EFD, the size of this angle, according to rule number 2 that states that the sum of angles on a straight line is equal to 180 degrees. So I will read rule number 2 again. Rule number 2 states that the sum of angles on a straight line is equal to 180 degrees. So actually BC is one of triangles ABC sides, or BC is one side of triangle ABC, therefore it is a straight line. Okay, BC is a straight line. Okay, BC is a straight line, therefore we can implement rule number 2 that states that the sum of the angle on a straight line is equal to 180 degrees. So if we focus at point F, we know according to rule number 2 that the sum of the angles on the straight line BC at point F must be equal to 180 degrees, that is to say P plus Q plus angle DFE must be equal to 180 degrees according to rule number 2. Again, the sum of the angle on the straight line BC at point F must be equal to 120 degrees according to rule number 2. Therefore, P plus Q plus angle DF plus angle DEF or plus angle DFE must be equal to 180 degrees. But we have already found out that P plus Q equals to 120 degrees, so we can substitute P plus Q by 180 degrees by 120 degrees, because P plus Q equals to 120 degrees. We will get that 120 degrees plus angle DFE equals to 180 degrees. So here we'll subtract from this equality 120 degrees, and we will get that the size of angle DFE, the missing angle, equals to 180 degrees minus 120 degrees is 60 degrees. Okay, we found out that the size of angle DFE is actually 60 degrees. Okay, now we know that in triangle DFE, the green triangle, DF equals to FE. It is given us in the question that DF equals to FE. We know that DF equals to FE. Therefore, according to rule number 1, that states that in front of equal sides in the triangle there are equal angles. In front of FC we have angle FDE, this angle, and in front of DF we have angle FED, this angle. So if we define angle FED as Y, then angle FDE, this angle must be also equal to Y, because of the fact that those two angles are located in front of equal sides, therefore they are equal to each other according to rule number 1. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle DFE, the sum of the angles is equal to 180 degrees. That is to say, Y plus Y, that is 2Y, plus 60 degrees, must be equal to 180 degrees. Okay. So here we will subtract 60 degrees from this equality, and we will get that 2y equals to 180 degrees minus 60 degrees is 120 degrees. Here we will divide this equality by 2, and we will get that y equals to 120 degrees over 2 is 60 degrees. So we found out that the size of angle y is 60 degrees. So here we can write that this angle equals to 60 degrees, and also angle FED equals to 60 degrees. Actually, a triangle DFE, the green triangle, is a right triangle because all of its angles are equal to 60 degrees. Therefore, all the sides of an equilateral triangle are equal to each other. So, side DE must be equal to side DF, that must be equal to side FE. And if we define BF as X, then all the other sides that are marked with two blue lines are equal to each other. So FC also equals to X, FE also equals to X, and DF equals to X, and also DE also equals to X. Okay? So in the next step we will find and the size of angle ADE, the size of this angle, and the size of angle AED, according to the rule that states that the sum of the angles on a straight line is equal to 180 degrees. Actually, AB is the side of triangle ABC, therefore it is a straight line. Therefore, we know that the sum of the angles on the straight line equals to 180 degrees. Therefore, if we focus at point D, we know that the sum of the angles at point D on the straight line AB must be equal to 180 degrees according to rule number 1. That is to say, B plus 60 degrees plus the size of angle ADE must be equal to 180 degrees according to rule number 1. Again, B plus 60 degrees plus angle ADE equals to 180 degrees. Here we will substitute we will subtract 60 degrees and also B from this equality, and we will get that angle ADE equals to 120 degrees minus 60 degrees is 120 degrees minus B. Okay, but we have already found out in equation number 1 that B plus C equals to 120 degrees. Therefore, for equation number 1, we will get that C equals to 120 degrees minus B, and subtracted B from equation number 1, and we got that C equals to 120 degrees minus B. So here 120 degrees minus B equals to C according to equation number 1. So actually, from this equality, you can derive that angle ADE equals to C. Angle ADE equals to C. Okay, angle ADE equals to C. So angle AD equals to C, so this angle is C. And we will repeat on the same process on the other side of triangle ABC. We know that AC is one side of triangle ABC, therefore it is a straight line. So at point E, we know that the sum of the angles at point E on the straight line AC must be equal to 180 degrees. That is to say, C plus 60 degrees, angle C plus 60 degrees, plus the size of angle AED must be equal to 180 degrees. Okay, that is according to equation number 2. The sum of the angles on a straight line equals to 180 degrees. So we will subtract 60 degrees and C from this equality, and we will get that angle AD equals to 180 degrees minus 60 degrees is 120 degrees minus C. Again, we have already found out in equation number 1 that B plus C equals to 120 degrees. So from equation number 1, we will get that B equals to 180 degrees minus C. I subtracted C from equation number 1, and I got that B equals to 120 degrees minus C. So here 120 degrees minus C actually equals to B according to equation number 1. So from this equality we can derive that angle AED equals to B. Okay, angle AED equals to B. So this angle AED equals to B. So in the next step we'll prove that triangles ABC and triangle ADE are similar triangles. So we'll focus on triangle ABC and triangle AD. The small green triangle. So in triangles ABC and triangle ADE, angle AED equals to angle ABC. Okay, and both those two angles are equal to B. Angle AED is equal to angle ABC in triangle ABC, and both those two angles are equal to B. Okay, and also we know that angle ADE is equal in triangle ADE is equal to angle ACB in triangle ABC, and both those two angles are equal to C. Again, angle ADC is equal to angle ACB, and both those two angles are equal to C. Okay, and also we have a common angle. This angle is a common angle because it belongs both to the small triangle ADE, and angle A equals also, angle A belongs also to the big triangle ABC. So angle A equals to angle A. It is a common angle. So we actually proved that all the three angles of the big triangle, triangle ABC, are congruent to all the three angles of triangle ADE. Therefore, we actually proved that triangle ABC is similar to triangle ADE according to angle similarity rule. Okay, triangle ABC is similar to triangle ADE according to angle similarity rule. Angle similarity rule states that if two triangles have three angles that are congruent, then those two triangles similar to each other. Okay, and also we have rule number 4, that's rule number 3, that states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. So I will read rule number 3 again. Rule number 3 states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. Okay, so actually in our two similar triangles we can implement rule number 3. According to rule number 3, the area of triangle ABC, that is the sign for the area, that means that is the area of triangle ABC over the area of triangle ADE, will be equal to the square ratio of the corresponding sides. That is to say, it will be equal to BC square over DE square. Okay, BC and DE, they are the corresponding sides. So it is BC square over DE square. But what is the value of BC? BC equals to x plus x, that is to say BC equals to 2x and BC square is 2x square. And what is the value of DE? DE equals to x, so DE square equals to x square. So here we have 2x squared over x squared. 2x squared is 4x squared over x squared. 4x squared over x squared is 4. So actually the ratio between the area of triangle ABC over the area of triangle ADE, the small green triangle, is equals to 4. So if we multiply this equality by the area of triangle ADE, we will get that the area of triangle ABC is equals to 4 times the area of triangle ADE. Okay, so we found out that the area of triangle ABC equals 4 times the area of triangle ADE. In the next step, we will calculate the area of quadrilateral BDEC. Okay, so the area of quadrilateral BDEC will be equal to the area of triangle ABC minus the area of the small triangle, triangle ADE. Again, the area of quadrilateral BDEC will be equal to the area of the big triangle, triangle ABC, minus the area of the small green triangle, triangle ADE. Okay, so the area of quadrilateral BDEC equals to the area of triangle ABC minus the area of the small triangle, triangle ADE. Okay, the area of quadrilateral BDEC equals to the area of triangle ABC minus the area of the small triangle, triangle ADE. But we have already found out that the area of triangle ABC equals 4 times the area of triangle ADE, so we can substitute the area of triangle ABC by 4 times the area of triangle ADE. Okay, so the area of quadrilateral BDEC equals to the area of triangle ABC is actually 4 times the area of triangle ADE minus 1 times the area of triangle ADE. So actually 4 times the area of triangle ADE minus 1 times the area of triangle ADE equals 3 times the area of triangle ADE. And that is the area of quadrilateral BDEC. Okay? Again, the area of quadrilateral BDEC equals to 4 times the area of triangle ADE, and we already found out that the area of triangle ABC equals to 4 times the area of triangle ADE. Okay? In the next step, I will present to you a new formula for the area of any triangle. So if we have triangle ABC so this is triangle ABC. We know that the size of side AB is A, and the size of side AC is B, and the angle between AB and AC is theta. Then the area of this triangle, triangle ABC, will be equal the area of triangle ABC equals to A times B times sine theta over 2. Okay, the area of triangle ABC equals to A times B times sine theta over 2. We will calculate the areas of the big triangle EFC and the small triangle DBF according to the formula that I presented to you. Actually, the ratio between the area of the big triangle to the area of the small triangle is 15 over 8, and 15 over 8 equals to 15 is the area of triangle EFC, and the area of triangle EFC according to the formula that I presented to you will be equal to EF times will be equal to EF times FC times sine Q over 2. Okay, so the area of the big triangle EFC according to the formula that I presented to you will be equal to EF times FC times sine Q over 2. And the area of the small triangle DBF will be equal according to the formula that I presented to you. It will be equal to DF times BF times sine P over 2. Okay, that is the area of the small triangle DF times BF times sine P over 2. Here we move 2 to the numerator and DF times BF times sine P to the denominator. We get that 15 over 8 equals to 2 times EF times FC times sine Q over 2 times DF times VF times sine P. Okay, here 2 over 2 is 1, so 2 is cancelled, so we'll get that 15 over 8 equals to EF equals to X times FC. FC also equals to X, so it is X times X is X squared times sine Q in the denominator we have DF. DF is X times BF. BF is also X, so X times X is X squared. X squared times sine P. Okay, so we got that 15 over 8 equals to X squared sine Q over X squared times sine P. So here we have X squared over X squared is 1, so X squared is cancelled. So in total we got that sine Q q over sine p equals to 15 over 8. Okay? Sine q over sine p equals to 15 over 8. But we have already found out that q plus p, according to equation number 2, q plus p equals to 120 degrees. If we subtract p from equation number 2, we will get that q equals to 120 degrees minus p. Okay, q equals to 120 degrees minus p. So here we have sine q over sine p equals to 15 over 8. So we can substitute q in this equality by 120 degrees minus p from equation number 2. Okay, so we will get that sine q is 120 degrees minus p over sine p equals to 15 over 8. Okay, sine 120 degrees minus p over sine p equals to 15 over 8. So in the next step I will present to you trigonometric identity in order, and we will use the trigonometric identity in order to calculate the value of sine 120 degrees minus p. So actually the trigonometric identity is sine a minus b sine a minus b equals to sine a cosine b minus sine b cosine a. We will use this trigonometric identity in order to find out the value of sine 120 degrees minus p. So according to this trigonometric identity, the value of sine 120 degrees minus p will be equal to sine 120 degrees times cosine p minus sine p times cosine 120 degrees, and then sine 120 degrees minus p equals to sine 120 degrees equals to root 3 over 2 times cosine p minus sine p, and cosine 120 degrees equals to minus 1 over 2 and minus is plus, so we'll get that sine of 120 degrees minus p equals to root 3 over 2 times cosine p minus, and minus is plus, so it is plus 1 over 2 times sine p. Actually, we found out the value of sine 120 degrees minus p. So we have our original identity that states that our original equality that states that sine 120 degrees minus p over sine p equals to 15 over 8. Okay, so actually we will substitute sine 120 degrees minus p in this equality by the value of sine 120 degrees that we found here. Okay, so we'll get that. So instead of sine 120 degrees minus p, we will write down this expression that equals to sine 120 degrees minus p. That is actually root 3 over 2 times cosine p, and we must divide all by sine p, or sine p, plus 1 over 2 times sine p over sine p. This equals to 15 over 8. So we actually found out that root 3 over 2 times cosine p over sine p plus 1 over 2 sine p over sine p is 1, so sine p is cancelled. So, and cosine p over sine p is cotangent p, so I will write it down. Root 3 over 2 times cotangent p plus 1 over 2 equals to 15 over 8. Here we will subtract 1 over 2 from this equality. Actually 1 over 2 is 4 over 8, so we will subtract from 4 over 8 from this equality, and we will get that root 3 over 2 times cotangent p equals to 15 over 8 minus 4 over 8. And 15 over 8 minus 4 over 8 is 11 over 8. 11 over 8, and it is equals to root 3 over 2 times cotangent p. Okay, but we have another trigonometric identity. That cotangent p equals to 1 over tangent p we have trigonometric identity that states that cotangent p equals to 1 over tangent p, so we will substitute cotangent p in this equality by 1 over tangent p, and we will get that root 3 over 2 times tangent p equals to 11 over 8. got that root 3 over 2 times tangent p equals to 11 over 8. Here we will multiply this equality by tangent p, and we will get that root 3 over 2 equals to 11 over 8 times tangent p. Here we will multiply this equality by 8 and then we divide it by 11 in order to get the value of tangent p. So we will get that 8 times root 3 over 11 times 2 equals to tangent p. Okay, here we have 8 over 2 is 4. So in total we got that tangent p equals to 4 times root 3 over 11. So we actually found out the value of tangent p. Tangent p equals to 4 times root 3 over 11. But as you already know, tangent is a function that describes the relationship between the sides of a right triangle. So actually this we can actually write this, we can draw this equality, because if we have a right triangle with angle P, this is a right triangle and this is angle P. Actually, if this side is equals to 4 times root 3 units and this side equals to 11 units, then tangent P in this drawing, tangent P equals to 4 times root 3 over 11. So this drawing actually describes exactly the function that we have here, the equality that we have here. So if this drawing describes this function, then from this drawing we can also get the value of sine p. The value of sine p will be equal to the side that is in front of sine p, or that is in front of angle p, that is actually 4 times root 3 over the hypotenuse. And what is the size of the hypotenuse? According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And the sum of the squares of the perpendiculars is actually 11 square plus 4 times root 3 square. So 11 square plus 4 times root 3 square is the square of the hypotenuse, but we don't want the square of the hypotenuse, but we want the hypotenuse itself. So the square root of the hypotenuse, if we take a root from the square of the hypotenuse, we will get the hypotenuse. So the root of the square of the hypotenuse equals to the hypotenuse. So the hypotenuse equals to 11 to the root of 11 square plus 4 times root 3 square, all in root. So 11 square is 129, 121, and 4 times root 3 square is 48. 48 plus 121 is 169, and the root of 169 is 13. So in total we got that sine p equals to 4 times root 3 over 13. Okay? And in the next step we will find again the area of this triangle. The area of triangle DBF equals to x times x times sine p over 2. So it is x squared times sine p over 2. That is the area of this triangle, but we know that the area of this triangle, triangle DBF, equals to 8 square units. Okay? So we know that the area of triangle DBF the area of triangle DBF equals to x squared times sine p over 2. Okay, but we have already found out that the value of sine p is 4 times root 3 over 13. So we can substitute sine p in this equality by 4 times root 3 over 13. Okay, so we'll do it now. X squared over 2 and sine p equals to 4 times root 3 over 13. So it equals to 8, and 4 over 2 is 2. So we got that 2x squared times root 3 over 13 equals to 8. Here we'll divide this equality by 2, and we will get that x squared times root 3 over 13 equals to 4. Okay, we found out that x squared times root 3 over 13 equals to 4. So here we will multiply this equality by 13, and then we will divide it by root 3 in order to get the value of x squared. We will get that x squared equals to 13 times 4 is 52. 52 over root 3 is the value of x squared. In the next step, we will calculate the area of the equilateral triangle, triangle EFD. The area of triangle EFD will be equal to x times x, that is x squared, times sine 60 degrees, that is root 3 over 2, all divided by 2 is root 3 over 4. So we found out that the area of the equilateral triangle, triangle EFD, equals to x squared times root 3 over 4. But we have already know that x squared equals to 52 over root 3, so we can substitute x squared in this equality by 52 over root 3. So we'll do it, and we will find out that the area of triangle EFD equals to x squared is 52 over root 3 times root 3 over 4. Okay, that is the area of triangle EFD, the equilateral triangle, triangle EFD. So here we have root 3 over root 3 is 1, and 52 over 4 is 13. So we found out that the area of triangle EFD equals to 13 square units. So we can write down that the area of triangle EFD equals to 13 square units. And what is the area of triangle DBEC? The area of the area of quadrilateral DBEC will be equal to the area of triangle DBF, that is 8 square units, plus the area of the equilateral triangle DFE, that is 13 square units, plus the area of triangle EFC, that is 15 square units. So in total, we found out that the area of quadrilateral DBEC equals to 8 plus 13 is 21, and 21 plus 15 is 36 square units. Okay, so the area of quadrilateral DBEC equals to 36 square units. But we have already found out that the area of equilateral DBEC equals to 3 times the area of triangle AED. And we know that the area of triangle DBEC equals to 36 square units. So from this equality, we can derive that 3 times the area of triangle AED equals to 36 square units. Okay, 3 times the area of triangle AED equals to 36 square units. Okay, here we will divide this equality by 3, and we will get that the area of triangle AED equals to 12 square units. Okay, the area of triangle AED equals to 12 square units. So here we can write that the area of this triangle AED equals to 12 square units, and the area of the green shape or the green quadrilateral ADEF will be equal to the area of triangle, the equilateral triangle DFE, that is 13 square units, plus the area of triangle ADE, that is 12 square units. So in total, the sum of those two areas is 25 square units. So the area of quadrilateral ADEF equals to 25 square units. Okay, again, the area of quadrilateral ADEF, the green shape, equals to 25 square units. Okay, so now I've summarized the lecture. Actually, we wanted to find out the area of the green shape, or the area of quadrilateral ADEF. We know that angle DAC or angle BAC of triangle ABC equals to 60 degrees in its size. And we also know that triangle DBF equals to 8 square units, and triangle EFD equals to 15 square units. The area of triangle EFC equals to 15 square units. And we also know that BF equals to DF equals to FC, that equals to FE. And we want to find out the area of the green quadrilateral ADEF. Okay. Actually, we know that the sum of the angles in any triangle equals to 180 degrees. So we defined angle ABC as B and angle ACB as C. And again, the sum of the area of the angles in triangle ABC equals to 180 degrees. That is to say 60 degrees plus B plus C must be equal to 180 degrees. Okay, 60 degrees plus B plus C equals to 180 degrees. We subtracted 60 degrees from equation number 1 and we got that B plus C equals to 120 degrees. And we have rule number 1 that says that in front of equal sides in the triangle there are equal angles. So if AB equals to AC in triangle ABC, then those two angles are also equal to each other. That is to say, angle ABC equals to angle ACB. Those two angles are equal to each other. So in triangle BBF, we know that BF equals to DF. Therefore, according to rule number 1, those two angles are also equal to each other, because those two angles are located in front of equal sides, therefore they are also equal to each other. If this angle is B, then this angle also must be equal to B. And the same thing about triangle EFC. In triangle EFC, we know that FC equals to EF. FC equals to EF. Therefore, in front of those two angles, we have those, in front of those two sides that are equal to each other, we have those two angles. And if this angle is C, then this angle must be also equal to C, because in front of equal sides in the triangle, there are equal angles. Those two angles are located in front of equal sides, therefore they are equal to each other according to rule number 1. So if this angle is C, this angle is also C. So, and then we defined angle DFB as P and angle EFC as Q, and the sum of the areas in triangle DB, the sum of the angles in triangle DBF equals to 180 degrees. That is to say, B plus B plus P equals to 180 degrees, or 2B plus P equals to 180 degrees. We subtracted P from this equality and we got that P equals to 180 degrees minus 2B. Then in triangle FEC, this triangle, we know that the sum of the angles in this triangle is 120 degrees. So C plus Q equals to 180 degrees, or 2C plus Q equals to 180 degrees. Then we subtracted 2C from this equality and we got that angle Q equals to 180 degrees minus 2C, and we already found out that P equals also to 180 degrees minus 2B. Then we added Q to P, so Q plus P equals to 360 degrees minus 2C minus 2B. And then we take out the common factor of this expression, and we got that Q plus P equals to 360 degrees minus 2 times B plus C. But we already know that B plus C equals to 120 degrees, so we can substitute B plus C in this equation number 2 by 120 degrees. So we substituted this by 120 degrees, and we got that Q plus P equals to 180 degrees, and we already found out that B plus C equals to 120 degrees. Okay, and then we have rule number 2 that states that the sum of the angles on a straight line is equal to 180 degrees. And we know that BC is a straight line. Okay, BC, because BC is the side of triangle ABC, therefore it is a straight line. And according to rule number 2, the sum of the angles in the straight line BC equals to 180 degrees. And especially at point F, the sum of the angles at point F on the straight line BC equals to 180 degrees. So P plus Q plus the size of this angle equals to 180 degrees. Okay, P plus Q plus the size of angle DFE equals to 180 degrees according to rule number 2. So but we have already found out that P plus Q equals to 180 degrees, so we can substitute P plus Q by 120 degrees. We substituted P plus Q by 120 degrees, and we found out that angle DFE equals to 60 degrees. So this angle equals to 60 degrees. Then we connected together points D and E by a straight line. And in triangle DEF, we know that DF equals to EF. Therefore, according to rule number 1, in front of equal sides in the triangle, there are equal angles. So those two angles must be equal to each other. If one angle is defined as y, then the other angle must be also defined as y because they are equal to each other. So, and we also know that the sum of the angles in any triangle equals to 180 degrees. That is to say 2y plus 60 degrees equals to 180 degrees. So we subtracted 60 degrees from this equality, and we got that 2y equals to 120 degrees. We divided this equality by 2, and we got that y equals to 60 degrees. So this angle equals to 60 degrees, and this angle also equals to 60 degrees. So we have here an equilateral triangle, and in an equilateral triangle all the sides are equal to each other. So if this side is x, so this side is also x, and this side is also x, and all the line segments that I marked with 2 blue lines are also equal to x because all are equal to each other. So BF is x and CF is x, and all the other also DF is x and EF is x, and also DE is x. Okay, then we calculated the sizes of those two angles according to the rule that the sum of the angles on a straight line equals to 180 degrees. So if we look at AB is the side of triangle ABC, therefore it is a straight line. So actually the sum of the angles on the straight line AB equals to 180 degrees. That is to say, if you focus on at point D, B plus 60 degrees plus angle ADE must be equal to 180 degrees according to rule number 1. So here we subtracted B at 60 degrees from this equality, and we got that angle ADE equals to 120 degrees minus B, but we have already found out that B plus C equals to 120 degrees. From question number 1, we got that C equals to 120 degrees minus B. So here we have 120 degrees minus B, and according to question number 1, it equals to C. So from this equality, we can derive that angle ADE equals to C. angle ADE, this angle equals to C. And we repeated on the same process on the other side. We know that AC is one side of triangle ABC, therefore this is a straight line. And we know that the sum of the angles on the straight line equals to 180 degrees. So if we focus at point E, we know that angle C plus 60 degrees plus the size of angle AD must be equal to 120 degrees. So we subtracted C and 60 degrees from this equality, and we got that angle AD equals to 120 degrees minus C, but we know that B plus C equals to 120 degrees. We subtracted C from equation number 1, and we got that B equals to 120 degrees minus C. So here 120 degrees minus C equals to B according to equation number 1. So from this equality we can derive that angle AED equals to B. Angle AED equals to B. So we found out those two angles, and then we focused on triangle ABC and triangle AED. On those two triangles, we know that angle AED equals to angle ABC. Those two angles are equal to each other, they are equal to beta. And also we know that angle ADE equals to angle ACB. And those two angles are equal to C. And angle BAC is a common angle. It belongs both to triangle ADE and also to triangle ADC. So angle A equals to angle A. So we actually proved that all the angles in the big triangle, triangle ABC, are congruent to all the three angles from triangle ADE. Therefore we proved that triangle ABC is similar to triangle ADE according to angle similarity. And we have also rule number 3 that relates to similar triangles. According to rule number 3, the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. Okay, so if we divide the area of triangle ABC by the area of triangle ADE according to rule number 3, we get it equals to the square of the square. It equals to square ratio of the corresponding sides. That is to say, it equals to BC square over DE square. Okay, but we know that BC equals to x plus x, and x plus x is 2x, and DE equals to x. So BC square is 2x square, and DE square is x square. 2x square is 4x square, and 4x square over x square is 4. So the ratio between the area of triangle ABC to the area of triangle ADE is 4, or the area of triangle ABC is 4 times bigger than the area of triangle ADE. Okay? Then the area of the quadrilateral BDEC equals to the area of triangle ABC minus the area of triangle ADE. Okay, the area of quadrilateral BDEC equals to the area of triangle ABC minus the area of triangle ADE. But we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE. So we can substitute the area of triangle ABC by 4 times the area of triangle ADE. And we found out that the area of quadrilateral BDEC equals to 4 times the area of quadrilateral BDEC equals to 3 times the area of triangle ADC. And we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE. Then I presented to you new formula for the area of any triangle. The area of this triangle equals to A times B times sine theta over 2. Okay, then we actually divided the area of triangle EFD by the area of triangle DBF, and we calculated the area of triangle EFC according to the formula that I presented to you. The area of triangle EFC will be equal to x times sine q over 2. Okay, x times sine q over 2, and the area of triangle DBF equals to x times sine p over 2. Okay, and we got that sine q over sine p equals to 15 over 8. But we know that q plus p equals to 120 degrees. We will subtract p from this equation number 2, and we get that q equals to 120 degrees minus p, so we can substitute q in this equality by 120 degrees minus p, and we will get that sine 120 degrees minus p equals sine of 120 degrees minus p over sine p equals to 15 over 8. Okay, and we'll calculate the value of sine 120 degrees minus p according to a trigonometric identity of sine A minus B. Sine A minus B equals to sine A times cosine B minus sine B times cosine A. So we found out that sine 120 degrees minus p by using this equality, by this trigonometric identity, that sine 120 degrees minus p equals to root 3 over 2 times cosine p plus 1 over 2 times sine p. We substituted sine 120 degrees minus p by this expression, and we found out that tangent p equals to 4 times root 3 over 13. Okay, tangent p equals to 4 times root 3 over 13, and from this, by drawing this triangle, we found out that sine p equals to 4 times root 3 over 13, and we calculated the area of triangle DBF. It is equal to x times sine p over 2, or x squared times sine p over 2, and we have already found out that sine p equals to 4 times root 3 over 13, so we can substitute the value of sine p by 4 times root 3 over 13. We substituted it by 4 times root 3 over 13, and we found out that x squared equals to 52 over root 3. And then we calculated the area of the equilateral triangle EFD. The area of the equilateral triangle EFD equals to x squared times root 3 over 4, but we have already found out that x squared equals to 52 over root 3, and we substituted x squared in this equality by 52 over root 3, and we found out that the area of triangle EFD equals to 13 square units. So the area of triangle DFC equals to the area of triangle DBF, that is 8 square units, plus the area of triangle DEF, that is 13 square units, plus the area of triangle EFC, that is 15 square units. So in total, the area of quadrilateral DBEC equals to 36 square units. But we have already found out that the area of the equilateral DBEC equals to 3 times the area of triangle ADE. So from this equality we got that 3 times the area of triangle AD equals to 36. We divided this equality by 2 and we found out that the area of triangle AD equals to 12 square units. So the area of triangle, the area of the shape ADEF equals to the area of triangle ADE, that is 12 units, plus the area of triangle DEF, that is 13 square units. So in total the area of the quadrilateral ADEF equals to 12 plus 13, that is 25 square units. So the area of equilateral ADEF, the square shape, equals to 25 square units. Okay, thank you very much.